Dear students, why ClOH is called an acid but NaOH is called a base? Please see the question again. ClOH is an acid but NaOH is a base. Why? Today I will discuss about this question answer. But before starting the question answer, all of we have to know the definition of acid and base. As we know that there are different concepts are present in our chemistry about acids and bases. But most common and initial concept is Arrhenius' concept. For giving this question answer, we need only Arrhenius' acid-base concept. So, an Arrhenius acid is a compound or chemical species that increases the H plus ion concentration in aqueous solution is called acid. On the other hand, base. An Arrhenius base is a compound that increases the Weiss ion concentration in aqueous solution. Generally, we can say that a compound or chemical species which produce H plus ion in its aqueous solution is called acid, and a compound or chemical species which produce OH negative ion in its aqueous solution is called base. It's Arrhenius' concept. So the students see the compounds ClOH and NaOH. Both the compound has a common radical, that is OH. Initially, we can think that both the compounds may be base, but the reality is completely different because in aqueous solution ClOH produced H plus ion, so it is called acid, and in its aqueous solution NaOH produced OH negative ion, so it is called base. But now we have to know details. Please see the compound ClOH. It is covalent compound. Here chlorine, oxygen and hydrogen atoms are present. And we have to follow the Lewis dot diagram initially for understanding why ClOH produced H plus ion in its aqueous solution. ClOH is a compound which is actually a covalent compound because it has formed by sharing electrons with each other. Here oxygen is a central atom and hydrogen and chlorines are corner atoms. Oxygen has shared single electron with hydrogen and another single electron with chlorine for filling octet. Now, hydrogen has shared single electron with oxygen and chlorine has shared single electron with oxygen for filling octet and duet. Please see the structure or diagram. Hydrogen has shared single electron with oxygen for filling its duet. As we know that hydrogen filled duet, and chlorine has shared single electron with oxygen for filling its octet. As we know that there are 7 electrons are present in its outermost shell, and single has shared with oxygen that has made 8 electrons in its outermost shell. But central atom oxygen has also filled its octet by sharing 2 electrons both with chlorine and oxygen. And remaining 4 electrons, that means 2 lone pair electrons are present in oxygen atoms. It is Lewis dot diagram of ClOH. It is covalent compound, but it does not give a complete idea why ClOH is called an acid. Now we have to calculate its electronegativity with Pauling scale. Electronegativity of hydrogen atom is 3.5 and oxygen is 3.5 and hydrogen is 2.1 and chlorine is 3.00. So the electronegativity difference between oxygen and hydrogen atom is 1.4. and the difference of electronegativity between chlorine and oxygen atom is 0.5. Clear? Electronegativity difference 0.5, here electronegativity difference is 1.4. As we know that when the electronegativity difference is 0.5 or more, then both the atom side will create opposite pole. That means the compound will create polarity. Now see oxygen and hydrogen, between oxygen and hydrogen the difference of electronegativity is 1.4. So a positive pole has created at the end of hydrogen and a negative pole has created at the end of oxygen. Oxygen negative and hydrogen is positive pole has created. On the other hand, the electronegativity difference between chlorine and oxygen is 0.5. So, a positive pole has created at the end of chlorine. Now, oxygen has shared more electrons, that is, oxygen has shared 2 electrons. So, the shared electrons will shifted towards oxygen. So the sharing electrons will shifted towards oxygen atom. So the electronegativity will create at the end of oxygen, at the ending side of oxygen atom. And oppositely, a positive pole will create its opposite atoms, that is hydrogen and chlorine atom. But the positivity of chlorine and hydrogen is different because one is 0.5, another is 1.4. So the positivity of hydrogen atom is greater than that of chlorine atom. Now, if you mix this compound with water, then water will attract H plus ion towards itself. If you mix this compound in water, that means in its aqueous solution, water will attract H plus ion towards itself, and ClOH will split into two ions. One is ClO negative and another is H plus. That means it will produce proton or H plus ion. This is why ClOH is called an acid. This is the better concept for understanding why ClOH is called an acid. On the other hand, another compound is NaOH. As you know that NaOH is a electrovalent compound, that means ionic compound, because sodium has transport single electron to OH radical. This is why Na is plus and OH is minus. If you calculate more details, then you can calculate that oxygen and hydrogen has bonded with sharing electron, that has built OH ion by sharing electrons. That means OH has bonded by covalent bonds, but sodium and OH has bonded by transporting electron. That means it is, you can say it is a electrovalent compound. But in detail you can say that sodium hydroxide is electrocovalent compound. It is clear that sodium has transport single electron to OH. So Na is plus and OH is minus. If you mix this compound in water, then water will attract Na plus towards itself. If you mixed with it water, then Na plus will attract towards H2O. That means Na plus and OH minus will produce in its aqueous solution. So OH negative ion has produced by NaOH in its aqueous solution. So we can say that NaOH is a base. That's all for today.